Hey there. Hey, this is stream number 58, I think. And I'm going to be doing something completely different today. So, if you've seen my stream in the past or have watched my videos on YouTube, I have developed my own web server in C++, all on Twitch pretty much, except for some lower level libraries that I kind of borrowed from some previous hobby work. And there's a link below to my notebook. It's in OneNote. And under this log page here, you'll find, or section, I mean, you'll find a page for every stream. So up until now, I've been working on a web server, but I'm going to do a little bit of a transition this stream, and I'm going to work on making a Twitch bot. And hopefully later, also be learning how to play Botland, which is something completely different. And oh, someone's already chatting. Hey there, Multiple Pixels, how you doing? Yeah, so some announcements to get out of the way. If you notice, there's a sort of a time gap between last stream and this one. So I took pretty much a big break from Twitch. I was getting kind of overwhelmed, so I basically decided to nuke my schedule on Twitch and just kind of stream whenever I felt better. And so feeling better today. In the meantime, I did finish up work on the transport layer security stuff on the server. And yeah, I'm doing good. Finished up the work on transport layer security, or otherwise known as SSL, on the server side off stream. So if you're watching my previous streams and you're interested in that, it's all checked in. You can check it out. Let's see where I left off yesterday. Not yesterday, last stream, which was, what's that, 2 weeks ago? Roughly? Almost 2 weeks ago. So I had been working on using certificate authority certificates with my TLS decorator, and then I was going to plug it into my server. And I think I had done this much, and I had yet to do this one. So I ended up doing that off stream. Got it integrated, got it working. So my cat wants attention. So if you hear a meow in the background, that's my cat. Anyway, got the stuff working for the web server, and I was getting to the point where I wanted to move on to my other plans. So I had this roadmap here. Okay, so I've already updated it. In the past, it was all short-term stuff, was all web server. Now that that's sort of good and going, I had this idea, two ideas actually: make a Twitch bot and also make my own blog system. So I put Twitch bot up onto the short-term plate, and that's because I had made this bot called MathBot in a custom chat room that I had built up in my web server. And it's sort of a cool little toy. And I thought that would actually be a nice thing to put into Twitch. So that's what I'm going to working on today. Also, I'm helping out Adam13531, and I've been watching his stream, and I haven't played Botland yet, but I've been watching his stream, and he's just finishing up tutorials. And as soon as he's ready today, or maybe tomorrow or the next day, whenever he's ready, I was going to stream and or record myself going through the tutorials. So kind of waiting for a message from him to see if it's ready, and it could be any time. He could come into the stream and say, "Hey, go play Botland," and I'll have to say, "Okay, cool. We're gonna stash everything about the Twitch bot and go play Botland." So yeah, Twitch bot. So I did a bunch of research on this. I don't like doing the research on stream. Instead, I like to do it off stream, since I think it's kind of boring to watch, and then write notes. So if you actually wanted to see the notes, they're all here. So I first looked at the Twitch docs, quickly discovered two things. So for authentication, they use this OAuth protocol. And I won't bore you with the details, but you can click on any of these links if you want more information. But there's the OAuth protocol, and also the fact that Twitch chat uses, or it's based on internet relay chat, which is a really old standard way of doing chat rooms. And I kind of vacillated between wanting to write my own IRC client and just writing a Twitch specific interface. And what kind of decided it for me, if I have a link here, I think I had it somewhere. Okay, I can't find it, but at one point I found a message from a Twitch admin that says, yeah, it's based on IRC, But it's really supposed to be different, and it really doesn't implement IRC fully, and they might be moving away from it. So it made the decision for me that I should treat it differently. And in fact, if you go to their guide, they don't call it IRC. This is sort of another hint from me. If you go to the getting started, I think, they mentioned TMI. And at first I'm like, what is that? Too much information? But I believe it's Twitch Messaging Interface. So I'm like, so TMI, Twitch Messaging Interface, is roughly based on IRC, but we should treat it as something different. So that's what I'm deciding to do. I'm going to be calling the component I'm writing today either Twitch or TMI, Twitch Messaging Interface. And its first goal is going to allow us to basically redo what this getting started page from Twitch shows, but instead of using their JavaScript module, we're going to write our own stuff in C++. And we're going to reuse some stuff from my web server, especially the string parsing stuff. And we're going to be using the same workspace that I have built up, which has the web server, web client, all these libraries. And we're just going to be basically adding a new library, and let's get started, shall we? Okay, first things first, let's make a new directory. New directory. And I don't know why I can't make a directory at the top level. Can't figure that out. It's some problem with me and VS Code. What do we want to call it? Twitch? If I could spell it correctly. I added an S on the end so that I could change the case and not fight Windows over the case. Yeah, see, I can't move it around. So I'm going to switch to the console. And I'm going to move VS Code Twitch here. There we go. What to base it off of? Let's pick a simple library. SHA-1's a nice little simple library. We can just kind of copy everything, paste it here, and then start renaming. So SHA-1 is Twitch. This is a library which I guess we could say implements. Implements the what, though? Implements the formal and informal specifications provided by... Oh, this works now. I installed an add-on to auto wrap. It works, yay. Provided by Twitch TV for interfacing programs with the Twitch infrastructure. And that, my friends, is the overlay I throw up when I need to mute the mic in order to talk to people in the background. So apologies when I have to do that, but sometimes it's got to be done. Okay. Okay. The Twitch. Okay, it's not functions. How do I word this in something like this? Oh, okay, I see. So we'll envision that we'll have a Twitch. I'm thinking TMI or messaging interface. How about just messaging? Class. So how is this raised? Yeah, class is used to connect to Twitch chat. Receiving incoming messages from the Twitch server, chat server. And hey there, Rally Monkey. Thanks for the bit. Oh my goodness, I didn't notice that before. Raimu messaging interface. RMI, yeah. Receiving incoming messages from the Twitch chat server and allowing the program to, how do you say it? Send to participate in chat. The idea is I'm going to make a chat bot, which is a program, which will use this class. Pretty simple, right? It's actually hopefully going to be a lot simpler to make a Twitch bot than it was to make the web server. Okay, so this is all boilerplate, although I can do this now. Haha. And haha. That work? I don't know how I like wrapping so. That's actually not too bad. We'll keep it. All right, license, standard MIT license. This is now Twitch. I'm envisioning a class called messaging, right? Yes. All right, maybe I'll go over a little bit in case you're the first time watching and you're not sure what I'm doing. So I'm programming in C++, but I'm using a tool called CMake to make the build system. Use CMake because if I'm on Windows, I can use CMake to generate Visual Studio project files for me. If I'm on the Mac, it'll generate Xcode project files for me. And if I'm on Linux, it'll make new make files. So it's very versatile and lets me switch operating systems pretty easily. The downside is CMake has its own language. It looks like this. And oh, you watched a 30-second ad in order to earn the bit? How did you earn the bit? Someone was talking about that earlier. You can watch ads now to earn bits? You need to look into that. Anyway, this is a special language you have to kind of get used to and learn to use CMake. And just really briefly, since this is pretty simple for a library, there's not much here. The key statement is this add library. And this is variable expansion. I like to set variables at the top if I can, and then use them, since you can see I use it 3 times. The library is going to be named whatever this variable is, which is Twitch. So it's going to add a library called Twitch. Static means we're going to make it a static link library as opposed to a loadable module or dynamic link library. And then everything else on the add library are all the source files, header files, resource files, everything that you need to pull together. And CMake kind of knows, based on what kind of build system you tell it to generate, what needs to be done. So like if you include the CPP file, it knows to make a rule in the build system to build it. HPP file, it doesn't need to build that, but it will put it into the IDE so that you can see it. So that's the key statement add library. These other things around it are, the ones before it are setting up my variables, because I like to list my header files and source files separately. And the ones after are sort of augmenting. So set target properties, the property folder libraries, that's going to make the library show up in the libraries folder in the IDE right here. See how SHA-1 shows up there? And then target include directories says to anything linking with our library where to find the header files. So include. That means if you do pound include Twitch/messaging HPP, it finds that, that finds that HPP file because we listed include as a target include directory. And then this, last but not least, is telling CMake that we're going to have more code in a subdirectory called test, which is a good segue into explaining a little bit of my coding, what do you say, procedure, like how I go about writing code. It's a little bit different. You might have heard of this, or you can look it up. It's called test-driven development. And the idea is before you write code, you write a test. And the test starts off failing because you have no code. The test is basically checking to make sure that your code does the right thing. If you have no code, of course, it's not going to do the right thing, so it fails at first. And your test specifies what your code is supposed to do, so it's also sort of a documentation and specification for your code. So you write the test first, then you write the code to make the test pass. I use Google Test Framework. So if you look at the CMake for my tests here, they for target link library, kind of like target include directories, target link library says what other dependency libraries we need, and one of them is this gtest main. That's a Google test framework. As long as you link with that and include gtest.h, you can use these macros that look like this. Test basically specifies some code that you want to run to test something. And the first name here is just to group it up. So we can have several tests if we want that are all grouped together under SHA-1 tests. And then each one is an individual test. And this is a simple set of tests where we have no fixture or common setup. I'll show you later, probably, or we can look at it now. See if I can find it here. One that has a fixture. I'm not very good at finding stuff sometimes. Something more complicated. Yeah, so here's fixtures and mocks. So if you make a class derived from testing test, it gives you some code that's run this setup before every test, and then tear down run code after every test. And you just add this underscore f, and now you're using that test fixture. Why the switch to science and technology? Because they got rid of communities. So there's no more creative community. So I had to select a category, and the closest was science and technology. There's no creative category anymore. And they added this thing called tags. So I think I just added software development tag. So yeah, it all changed today apparently. So yeah, anyway, if I needed common setup and teardown for a test, I would make a class called a fixture, and then we just need to add underscore f, and now we're using the fixture. But back to this stuff, right? Right here. Yeah, Google test. Right, so we include Google test, and we include the thing that we're testing. So that will be messaging. And I need to rename the file to messaging tests. And let's go here and just change all references to SHA-1 to messaging. And this is going to be the Twitch messaging class. Right? And let's clear out all the old code. And I don't know, what tests do we want? So this is where we kind of get to brainstorm what do we want our code to do? So let's think about how Twitch chat works. The first thing you need to do is log in, right? Log into chat. And we might want to have code to check out log out of chat, right? And then another one maybe receive not so good with words sometimes. Receive or listen for other people chatting. Receive messages, I guess. And how about send a message? So that's a good set of tests. And I'm going to clean this up a little bit. We don't know what other headers we might need yet, so I'll just clear them out. And just looking around here, just clearing out stuff we don't need. SHA-1 becomes messaging tests. This is gone. Right. This statement allows the test, if it wants to reach directly into, like, say, the source directory, if it wanted to test something internal. Don't think I need that, but I'll keep it around for now. This statement here, add test, is used if you use the CMake tool, the CTest tool. So I do that before every stream just as a sanity check. And when you do that, it looks, basically the build system that CMake makes adds a hook for every one of these add test statements, and CTest knows to look for those hooks, so it knows where all your test programs are. Each one of these test directories ends up building a single program, and so I have 14 of them now. And we'll be making a 15th now called messaging tests, right? Or no. Actually, I think I want to call this Twitch test, don't I? Yeah, I'll be making a 15th one called Twitch tests. Twitch tests will have messaging tests. I'm thinking that we'll have messaging, but we'll maybe want to grow this library in the future to have other things like PubSub and WebSocket-based chat and other things that aren't strictly messaging. Right, okay. I think we're good. Okay, this needs to be fixed. Twitch. Messaging. Okay. We'll fix this to say Twitch messaging. I'm gonna replace the one SHA one with 2 colons in front. And then replace this one with, oh hold on, that's not gonna do the right thing, is it? This thing should say Twitch. This thing should say messaging. Okay, clear out this stuff. Actually, I want to steal from another class. So I'm going to take this. Just sort of to capture the boilerplate. How much this boilerplate do I want? All the way down to here. Okay. And let's clear this out. This class... let's say this class represents a user. I like the term user agent. It's used in other areas of programming, like to represent the program that acts on behalf of the user. This class represents a user agent for connecting to the messaging interfaces. Interfaces, we'll keep it plural, of Twitch. For doing things... By the way, I should get used to this. Now that I have a tool to do the wrapping for me, I can just hit Alt-Q to do that. For doing things such as connecting to chat, receiving chat messages, and sending chat messages. Alright. Class is messaging. Okay, by default, for lifecycle management, I think I'm going to make it all delete. So why do I have these 4 lines and why do I call them lifecycle management? Look up rule of 0, rule of 5. Basically, these 5 methods in modern C++ are the ones that you should either write none of them or write all of them. If you write none of them, then the compiler usually fills in what you need. If you write any one of them, you should write all of them because they kind of all together completely specify how your class is destroyed, copied, and moved. And notice how I don't include the constructors. They don't really belong in this set. It's just destruction, copying, and moving. Actually, technically, this is a constructor. Actually, these are both constructors, right? But they're not, the default constructor is not included. And the reason why you group them together is sort of a long-winded reason. I can't really explain it best. It's best to look it up. But my take on it is that if you only say, let's say you only provide code for how to move your class, but not how to copy it, the compiler might generate a copy constructor for you, but that might not do the right thing. Might not work with your move constructor, so you might have inconsistent semantics for how to use your class and cause problems. So it's sort of a good idea to define them at least, and you can say equals delete, which basically says, hey, this class can't be copied or moved. And I like to start out with that, and then when I find that I need to make the class copyable or movable, then I add them. All right, so we need a default constructor, and we need at least a destructor because I'm using the Pimpl pattern, which looks like this, where I don't list any private properties directly in my header file. I only have one private property exposed, and that's a unique pointer to an opaque structure, which you declare like this in order for this name to be within the scope of the class. And then we don't define what's inside that structure here in the header file. We define it in our implementation file. So our users don't have to know the details of what the class has as far as its private properties. And you get a clean separation between your implementation and your interface. So yeah, you can look that up too, the Pimpl pattern. And all the stuff in between we're going to delete for now. Basically, we want to start with minimal code just to get it to compile, and then specify the tests, get the tests compiling and failing, and then we write code to make the test pass. Okay. Close SHA-1. Close that. Right, okay. CPP file. Messaging. And then this part is Twitch. Twitch goes there. And this is the messaging class. Don't know what we need as far as these things. Should do the same thing here. We don't know if we need vector. Actually, where I copied from should have included memory, and this didn't have memory. Memory is the header that declares unique pointer. So we need at least that. Okay, so let's just fill in minimally what we need. And that is the destructor. And we can default it here. The reason you can't default it here is because at this point, this structure impl is not fully specified. It's opaque. So if you were to say equals default here, the compiler would be like, I don't know how to make a destructor at this point because I don't know what impl has yet. If we do it here, we can because, oh, this, by the way, it doesn't go in that namespace. You can here because we will specify it here. Struct message, oh, sorry. This should all be inside this Twitch namespace. Struct messaging impl. So when you do that, now you can do this because you know it's in impl. And that's also why, another reason why you have to have the constructor here. I like to have an underscore after the symbol, by the way. Some people like to do it this way. I don't, because I learned that if you were to capitalize that, this is technically a violation of the standard because supposedly all symbols beginning with underscore and a capital letter are reserved words. So I like to avoid that issue entirely by putting it at the end. It's just a style thing. All right. That should be minimally what we need. I like to comment that though. And I also like to copy. I don't like to write stuff from scratch if I can avoid it. Alright, I like to copy stuff when I can. And it's the messaging instance. Cool. Alright. So this library should build. We need to hook it into the rest of my workspace though. At the very top level, CMake lists, there will be a list of add subdirectories. We just need to add one for Twitch. Add subdirectory Twitch. Twitch, I can spell. Alright. Okay, so CMake dot from the build directory should rerun the construction of the build system. It'll detect the changes I made, and then when I go to Visual Studio, it'll say, oh, hey, the solution's been modified, reload it. And we should see Twitch show up. There it is. And then under tests, we should see, actually I needed that to, I wanted that to say Twitch tests. So what did I screw up there? Screwed up something. I close that. Probably here? No, here. Twitch tests. How did it end up being called messaging test though? Oh, that circle there means it's not saved. I guess I didn't save all my files. This is one thing I like about CMake, that if I make a mistake, I just fix it, run CMake, and then it just kind of gets magically fixed in the real build system. Right, so now it's Twitch tests. And I can build that, hopefully. And then I should be able to see it in C-test first, that it's now out of 15. So Twitch test is one of our test suites, I guess you call it. Right, so, and I can run it directly by doing Twitch debug tests, test debug Twitch tests. And they're passing because they're not actually doing anything. So we need to fix that. So I'm doing a subtle transition from VS Code to Visual Studio. I'm not completely comfortable using Visual Studio Code for everything, so I'm still using Visual Studio for the actual code writing and stuff like that. I'm getting closer to getting comfortable in doing everything in VS Code, but not everything yet. All right. So how do we expect to use Twitch messaging, right? We'll call it TMI for short. So we should be able to make one. And what? Just thinking out loud, we'll probably want to have a login. And it'll probably need what? A nickname and a password. And so we'll have to provide those. So const standard string, which means, hey, sourcefy, how's it going? Thanks for the bits. My goodness. So many bits. Actually really, really kind of you. I don't mean to joke. But I take it that people are getting bits now for watching ads. That's kind of cool. So let's see. What was I was going to include string. Yeah, I like to wait until I need a class before I include the library header that defines it. So nickname. I don't know. A good nickname. Ninja. Why not, right? And then, of course, I know Ninja's password. Well, you're number one now, Sourcefy. Let's see. Pass. If I could spell correctly. Password. I don't know. Well, I do know that it needs to, for Twitch, it needs to begin with. Oh, wait a minute. No, hold on. It's going to be, like what needs to go across the wire is something that looks like this, right? Some random text there. I'm thinking this part, why burden the user with having to know that? We'll just do that. And then what we'll do is we'll expect, this is how you actually do the testing. You use some Google test macros like this, expect equal nickname. And we need to have something that the TMI talks to. Just thinking out loud, we'll mock the Twitch server. So we'll have like a mock Twitch server. So mock server. And we'll be able to ask it, get nickname offered. And we'll expect that what the mock server says the client offered as its nickname matches that, right? That's a password, I know. Okay. Actually, we're going to call this token because the way it works is actually you have an OAuth token. And then we will expect OAuth plus the token for, actually, let me think about this. I think I have to do this or else the compiler will get confused, but I'm not sure. For get password offered. Does that sound right? Let's look at the manual. It actually talks about in this guide what you'll see in a successful connection. So pass, OAuth, and then the token, and then the nick. I guess we should also check that the password came first, right? So what's a good way of checking that? How about we just have our mock server log every line that comes in? So then we can just do this. I'm going to use vector. Vector of standard string. Mock server dot get, I don't know, get lines received. So we'll expect pass OAuth and then plus the token, right? And for the first line, the next line it should be nick and then nickname. All right. What else? Is that a complete specification for logging in? For now, I guess so. Oh, my goodness. Thanks for the bits, SourceFi. I appreciate that. I'm gonna have to come up with like some kind of point system. Actually, the chatbot I'm hoping to make is gonna ask math questions, and you get points for guessing the correct answer in time. So the bits thing makes me think maybe I should give people extra points if they cheer or something. I don't know. The whole point of me streaming isn't really to get bits or points or whatever. It's mostly just to share my hobby with you guys. And by the way, if you have any questions at any point, please stop me and ask. All right, so just thinking this is probably good enough for now. How do we log out of chat? I believe that's not really talked about here because I went through this, but I did notice way back in the RFCs there's a quit. Server must close. Yeah, let's expect our Twitch interface to do the right thing. So let's say we're already logged in. So let me think about this. Do we have to do the login stuff? I guess so. Can't log out without first logging in, but we really don't care to check this stuff. We will. Oh, I misspelled that mock server, didn't I? We'll tell the mock server clear lines recede. And then we'll have TMI do log out. And then we'll expect quit. And okay, I guess we can say what we want. What do I want to say? See ya, sucker. So we should see. Actually, let me pull that out. Farewell. We should see quit. Farewell. As the line received, right? Okay. I think, let me think about this. I have to figure out how. Yeah, this isn't complete, right? Because how log into what? To Twitch? How? How's it gonna get to our mock server? Have to report the bits on my taxes. Will do, sir. Okay. Log in is gonna open a network connection. Right? So instead of talking to the real Twitch and we want to talk to our mock server, we need to have like, yeah, we'll need to have the TMI will have a dependency, which is like what factory to call to make a new connection to Twitch. So let's think about what kind of factory. The normal factory would open a real network connection, but our fake factory will do something like this. So const auto connection factory. It will return the mock server. And we want it to... How do I specify this? I think it's like this. Shared pointer to system abstractions network connection. Or maybe we just keep it really generic and we just make a special interface. Yeah, I like that better. So it will be something like Twitch connection. Oh, I still need the shared pointer part though. Okay. Right, so we'll need memory. And we'll also need something else called connection, which we haven't defined yet. And then since this is a shared pointer, wherever we use that, it's also going to be a shared pointer. And I actually haven't made one, have I? We have to make one. So const auto mock server, make a shared one. And it's going to be mock server. Will be our implementation. We need to do this before the login, don't we? Do it there. And we'll do it here. This is a prime candidate for putting it into a fixture, so maybe I'll go ahead and do that. So fixture it is. Fixture, we just put F in front of everything. And then I steal from somewhere else where I made a fixture. Not there. This thingy. This is a fixture. So we have to make sure the name matches. We need to have it implement the testing test interface that Google Test gives us. And then for properties, we can put stuff that every test is going to share. So I think we'll move the TMI there. And that's the unit under test, right? And then this is old stuff, old stuff. Okay. Okay, we'll say this is used to simulate the Twitch server. And then here we'll have mock server, mock server. Oh, I need to make that a shared pointer, don't I? And actually I can move this make shared part there as well. Where was that? This part. Need to declare mock server though. We have this other kind of a mock. Alright, we'll just copy it. Mock. This is a fake Twitch server used to test the messaging class. Okay. So it has to implement Twitch connection, which we still haven't declared what that is, but we will in a second. Actually, let's do that now. Over to VS Code. And just take messaging and copy paste it. Call it connection. Do this first. So connection. And then I'll fix the case here. I know there's an add-on to do that, but I was lazy and did not research that enough yet. Okay, this is this meant to be an interface. This interface is required by the messaging class in order to communicate. Oh, with... Do you have a YouTube tutorial on how to connect to SQL Server DB? I've actually never connected to MS SQL Server DB. So sorry I can't help you with that. SQL Server? I'm used to using MySQL. And there it's you just use their client, right? Or use ODBC. It's been years since I've used database stuff though. Yeah, sorry I can't help with that. In order to communicate with the Twitch server. It's required. So it represents the network connection between the client and server. Good enough, right? So an interface doesn't need lifecycle management. In fact, everything about it is public. Just clear it out for now. So that's a perfectly valid interface. And just need to, I guess C comes before M. To list it, and then CMake dot it. Okay. Sometimes Visual Studio doesn't update until I close it and restart it, which is annoying. Okay, did it update? Yeah, there we go. So connection. Right, so our mock. What's our mock? Don't need that one. Don't need that one. Oh, what? Oh, I didn't get rid of this stuff. Setup, right. Did we have any common setup? I guess it was this one, this connection factory, right? And then we have to like give that to the TMI. So something like TMI.set connection factory. And we don't need teardown, I don't think. All right, so then we can remove this stuff. So notice how it knows TMI because because underscore F here, test underscore F, it knows this is a class, which is the fixture. And so we have access to TMI and the mock server from every test now. They don't need to do this stuff. Okay. So now we just have to get all this stuff to compile, right? No problem. Is this right? Oh, I think when you do that, you have to do that. Right. Yeah, and then to do that, I need to say this. Okay, that part's good. Hey there, Not Zane. What test framework? Yeah, I'm using Google Test. So you'll see it in my workspace here. Google Test. And I link it this way, gtest main, and include gtest test.h, and then our fixtures have to inherit testing test, and then you use test underscore f, and that's basically all you need to do to use Google Test. That and understand these macros to check expectations, actually do the testing. That's my summary of how to use Google Test in 30 seconds. All right. I should be really switching over to Visual Studio to do this stuff. Okay. Yeah, so we need to declare this stuff. So connection factory is one of our basic requirements. We need to be able to tell messaging class how to make a connection. So let's make a type. I like to list my types up here. So this is the type of function Now used by the class to create new connections to the Twitch server. Yep, using CMake. You've been on the channel before. You haven't noticed I use CMake? I must have been hiding that for a while. You have to teach your project group how to do C++, Visual Studio plus CMake isn't making it any easier. Yeah, you know, if you're just needing Visual Studio, don't use CMake. The only reason I use CMake is because I get both Visual Studio, Xcode, GNU Make, Ninja, and any other kind of build system kind of like for free. Well, not for free. I get it because I use CMake, but CMake has got a learning curve, right? You have to teach people how to understand this language. And I did that at the beginning of the stream a little bit, and I think I'm going to do that from now on, the beginning of each stream. Sort of say, like, this is the key statement. It tells the build system you're going to build a program, and here's where you list the source files, and here's how you specify dependencies, here's how you do the include paths. Yeah, and that takes some learning, so it doesn't make it any easier. It definitely makes it harder. Yeah, if you're teaching, definitely I would just use Visual Studio only if you're on Windows. Yeah. So we need functional, right? If we're gonna make a function. Yeah, I guess once I run CMake, I kind of switch over to Visual Studio and you don't really know where this came from, right? For all you know, I could have built this solution using Visual Studio, but yeah, it's all CMake. Okay, so type def standard function, and then we wanted it to return a shared pointer to a connection, right? Connection factory. All right, so it doesn't know connection. No problem. We can include Twitch. It's in this. They're both public headers, so I can just say connection. There's a shortcut there. Yeah. So we will just say we need one. And say this method is used to provide the class with a means of establishing connections to the Twitch server. Connection factory. There's a plugin to VS Code, at least, that auto-generates this template, but I'm lazy and I haven't looked into it. All right. This is the function to another one. Another add-on I could have is one that fixes my misspellings like that. This is the function to call in order to make a new connection to the Twitch server. Okay, so more of our tests should compile, yes. Not suitable. Did I not get that right? Oh, I didn't get that right. So this is the return value. We need to say what the arguments are. No arguments, right? Now it's good. Okay, this one, there's no login yet, so we need to define that. Login. It wants nickname and token, so that's 2 strings, right? Nickname, token, string. Do we have that? No, we don't have string. A lot of the times, me forgetting to put this include I don't catch it right away. It's only when I try to build on the Mac or Linux I catch it. Visual Studio is sort of forgiving as far as if you forget to include a header that you need. I've noticed. Okay, this method. By the way, when I'm writing this code, it's not going to be the final code. It's through writing the tests and then writing the code and then discovering what we did wrong, either specifying in the test or in writing the code, we'll discover things we want to change. So if you're like, login should return or throw something if it fails, well, I'll get there, don't worry. This method initiates, not initiates. Here I struggle with words again. You'll also notice that MSVC is much more forgiving than Clang G++. Yeah. So yeah, it's whenever I switch over to Clang and I get more warning messages too. It kind of makes me think I should be using the Clang toolchain in Visual Studio. You can do that now, by the way. If you go, I think it's C, C++ code generation, one of these. Maybe it was the general. Platform toolset, here we go. Okay, I guess I don't have it installed, but if you have it installed, you might have a Clang option in here for platform toolset. I think I just don't have it installed, but yeah, I need to maybe do that at some point. Because Clang is better at generating warnings and helps, it would help me avoid lazy code. Yeah, it does actually have Clang. Actually, let me run Visual Studio Installer. Blue. Can I do this without it wanting to update? See, I'm like one version behind. I want to modify. I'll show you where it is. It's somewhere, maybe under individual components. Compilers. Clang C2. They've said experimental for a long time. I think it's pretty stable. So yeah, they have the Clang front end. Okay, I guess it's not Clang all the way through and through. It's just the front end of Clang. Still with the Microsoft backend. But yeah, I've been meaning to try that out, hopefully to get better warning messages. I could just switch over to doing Linux development. Then I wouldn't have to worry about Microsoft stuff. Okay, this method, here's where I struggle with words. It's not that it logs in right away. It's going to initiate the process of logging in. So it starts the process of logging into the Twitch server. I think I want to make this asynchronous. That's smart. My tests are going to be more difficult if it's asynchronous. I think it has to be asynchronous because it might take a while before we know if it logged in successfully. Nickname. Token. This is the nickname to use when logging into the chat. Logging into chat. It should be the same as the user's Twitch account. Oh, I keep forgetting to do my wrap thing. Oh, except for there's this issue where it does, yeah. I actually filed a bug about that. Like, now it's working, but if I get rid of this blank line, it wants to fold those together. Bloom, sorry about that. Okay, this is the nickname to use when chatting, logging into chat. It should be the same as the user's Twitch account, except it should be, how do you say this? Except it's all lowercase. Except using only, except should be, except all in lowercase. Okay, how come you're not folding? Fold, damn it. Okay, really? Needs that line there? Now it's refusing to work. I broke it. There we go. Why is it not working here? Huh. It's broken. It was good while it lasted. Okay. This is the the OAuth token to use to authenticate with the Twitch server. All right. One line down. Next one. Get nickname offered needs to be something that we can ask the mock server. All right. I don't know. Don't know yet. Okay, what else? How come it still isn't like that? I thought I just added. Oh, because this needs to be an arrow. Okay, get password offered. I don't know. Get lines received. And here we can say nothing. Okay, clear lines received. And log out. I think I'm not going to really bother to document my mock classes that much because it's just sort of a waste of time, I think. This method starts process of logging out of the Twitch server. Right at the line there, 79 characters. Okay. Okay, now the good news is it'll probably compile. It's just not going to work. Then we start the long process of implementing the code to make it work. Okay, connection factory is not... Oh, I declared it, but I didn't provide a body for it. That's what this green squiggly is, actually. All right, here we go. Providing the bodies. We just do the minimal to make it compile. And log out. When I get to a state where it's building. Okay, so when we run the test now, it's gonna fail. Because like, well, we don't know what they offered, right? We don't know if they logged in. So I'm gonna change the test a little bit more because I wrote this thinking it would be synchronous. Like, as soon as this returns, we can check to make sure it was offered, but I think we're going to want to make it asynchronous. So I'm inclined to do this to make callbacks. So we'll have something like this: tmi.set logged in callback, or I've been calling it delegate. So let me stick to that terminology. And yeah, we'll have some kind of what am I thinking of? A Boolean logged in, and just because I know I'm going to need this, we will have condition variable and mutex. And that's fine. We're going to be doing some multi-threading here, so we're going to want to notify a thread that something happened, and then we're going to need to wait for it in our test. So you need three things: the state that you're waiting on and changing, and then a condition variable, which you can call it anything, wake condition, and then a mutex to wait for, or to use to synchronize. So just call it mutex. And what we will do is we'll capture all of those. In a lambda. And then we will say lock it. So mutex. And then logged in equals true. And then wake condition notify all. Actually, I'm going to say 1, because we know there's going to be only one thread. And then before we check what was offered, we'll do the wait here, and we'll say assert that it actually does happen that we log in. And that will be, oh, hold on. We need to do this while locking with the unique lock, because we're going to, a condition variable needs a unique lock, not a log guard. Lock guard is lighter. You use that when you don't need to wait or unlock. And by the way, what this does is it just takes this mutex and locks it when you construct the lock thing. And then when the function returns and this lock object is destroyed, it auto unlocks the mutex. That's what the lock guard does. And same thing with unique lock. Difference with unique lock is you can unlock the mutex without deleting the lock, which is what the condition variable does when we do this wait. So if we do a wait for, and we tell it the lock, and then we tell it a maximum timeout, let's say 100 milliseconds, and then the condition, return logged in. Basically, it'll say, wait up to 100 milliseconds for this function to return true, and then use this wake condition to receive the signal of the logged in being changed. And that condition variable and the flag here are both protected by this mutex using this lock. That's what that is. So I use this pattern a lot. I don't know if it has a name. It's sort of cumbersome. In other languages it might be easier to do, and I've thought about making a wrapper for that. But it is the official modern C++ way of waiting from one thread for something to happen in another, so that's what we're going to do. And this is the opposite end, right? So the idea here is we're giving TMI a function to call when it's successfully logged in, right? And it'll just say it's logged in. We won't have any arguments yet. Maybe we'll add them later. So we need to declare that. Now this is the type of function used to notify the user when the agent has successfully logged into the Twitch server. So right now it's got no arguments or anything. Logged in delegate. Right, so that's what I called it, right? Yeah, set logged in delegate, logged in delegate. And then I'm gonna sort of just copy this a little bit. Okay. Right. This method, right. Well, it's actually used to provide the class with, how about we'll simplify this. This method is called to set up a callback to happen when the user agent successfully logs into the Twitch server. And then this is the function to call all this stuff. When, I'd like to do the auto wrap thing here, but it don't, let's try again. Oh, it's like wrapping this section and not down here. Oh well. I should check to see if my GitHub bug request for rewrap, which is the plugin that does this, it's gotten any attention yet. All right, let's give that a body. Now everything should build again. It'll still fail. But let's make sure that this specification is complete now. So we set up something to be called when we're logged in. We tell it to start logging in. We wait for the login to complete. Once it's complete, we ask the mock server, well, did it provide us with the correct nickname and password? And were they in this order? So I think that's pretty much complete. Hey there, SetWho12. How's it going? How are the shaders? Yeah, I took like a week and a half off, and I'm kind of working on something different today. It's a Twitch bot, but using similar means and libraries. So doing that test-driven development stuff. Only instead of web server, we're hopefully going to be talking to Twitch later today. All right, so still failing because the code doesn't actually do anything. So it's basically saying we didn't log in and we didn't get, this is the other one, we didn't get anything when we tried to log out either. Oh, I need to kind of replicate this down here, don't I? Because the log out doesn't care about the login, let's take the login logic and kind of wrap that into a function. A convenience function here. We'll call it login. And we'll just strip it of any expectations here, so this will go away. Because we'll rely on the login test, log into chat test to actually test this, and elsewhere we'll just expect that it works because the other test would have told us if it didn't. So we'll say the convenience method which performs all the necessary steps. Actually, here I can do the auto wrapping right. To log into the. Whoa, it didn't quite work. I guess I have to terminate the comment to make it start working. Yeah, to log into the mock Twitch server. And then we can just call login from the logout test. And then skip all the other stuff here. Right, clear lines receipt. Actually, we'll build that into the login. Because why not? See ya, sucker. Okay. Now I think we have to actually have it start doing real things, so we go to the code. Right, so connection factory. We're going to need that in our state. I am going to totally copy my documentation. There. And same thing with the logged in delegate. Just get that out of the way. Huh, interesting. When I tell it to wrap, it doesn't like fix the indentation. Oh, I think because I turned that off actually. Yeah. Anyway, these ones are easy. These are just an assignment. Okay, but the login is a little bit more involved because we said before we wanted it to be asynchronous. So what I really want to do is pull in another library that lets me do all the thread stuff inside of a convenient wrapper class, but I haven't brought that into my stream setup yet. So we're going to still use traditional modern C++ thread, even though it's sort of gross. Because we have to, like the test does, we have to pull in all these things like condition variable and mutex, and then we have to worry about deadlocks. But I think for now it'll be okay. So this is used synchronize access to the object. That's what I usually say for a mutex, and this is used to signal the worker thread to wake up. Condition variable worker, how about wake worker? And then this flag indicates whether or not the worker thread should be stopped. And then last but not least, this is used to perform background tasks, the object. This probably has a name too. Oh, sorry, said Who12. I didn't see your comment from a little bit ago. You're working on a game you started, but you have some type of problem there's many ways to solve. I run into that sometimes. Many ways to solve, and you can't decide which solution to pick, right? Thread worker. Yeah, I know that feeling. You know what you can do is just pick one at random and see how it goes. And just keep in your mind that it's not final and that the objective is not to solve it right away, but to learn how to solve it. Okay, I'm inclined to make the worker start as soon as the object is created and then stop in the destructor. Because it's kind of convenient that way, because we can just do this. We can say lock guard. Oh, wait a minute. Inside of a scope. Decal type mutex. We say stop worker. Oh, this all has to have Pimpl in front, by the way. True. And then Pimpl wake worker notify 1. And then we can say Pimpl worker join. Then I don't have to check if it's joinable. I know this only runs once, this only runs once, so we can just say Pimpl worker equals standard thread worker Pimpl get. And then I just need to make a thread here. So these are the properties, and then here are the methods. Okay, this runs in its own thread and performs background tasks for the object, right? So void worker. So the generic thing here is we will have a unique lock. Decal type mutex. And we'll say while not stop worker. Do some stuff, and eventually, when we're done for a while, we will say, what would we say? Wake worker dot wait for, no, just wait, and then lock, and then the predicate is this. Right now, it's just return stop worker. That's the only thing it will wait for. But other things it might want to wake up for, we'll have to add here. Right. And what did I do wrong here? Oh, no underscore. Alien language, huh? It's modern C++, man. It is kind of weird. It might be looking worse because of the way I write things. Like, I have this extra space here and here, and I use decal type instead of just saying standard mutex. I like to put standard in front. A lot of people don't like that. They'll put something at the top, like using name. I think it's using namespace standard. Then you don't have to say standard : everywhere. So there might be a lot of that going on to make it look weird. But yeah, it's an older language, right? Newer languages are gonna look a lot different. Okay, I think that's enough. That's a lot of the boilerplate out of the way. Now we just have to, we want to do the logging in asynchronously, which basically means our worker is going to do all the real work. And these login and logout are just going to be instigators. So they're going to eventually do a lock, actually not eventually, but right away. Called type. And then I was asking someone to stop whistling in the background. You probably didn't hear it, but just in case. So having custom scopes inside your functions. Oh yeah, I actually don't really like it when I do that. It's sort of what they call, this is what they call sort of a code smell. The reason why I'm having to do this is because you don't want to wait on something while you are holding a lock, because the worker is going to be also getting the same lock. So if we were holding the lock and we tried to join the worker thread, it would actually deadlock. So putting inside this scope makes sure that this lock is unlocked. You know, I don't like it because it looks weird, but there's the only other way to do this would be to do lock.unlock. Two problems with that, right? LockGuard doesn't have an unlock. The other problem is if there's more than these 5 lines of code and there's like ifs and elses and loops, there could be bugs where I forget to unlock or I unlock twice. So this is sort of a compromise. It has this gross looking extra indent level, but we're guaranteed to unlock the lock once and only once by just leaving the scope, right? One thing I could do to maybe improve this is I could put this into a function. Yeah, why don't we? I'll do that. What the heck, we'll do it. So we'll say this method signals the worker thread to stop. And then this is refactoring, right? We're extracting this method and putting it here. Stop worker. And then I get the extra benefit of I can remove these impls. And then I simply say impl stop worker. So maybe that's a little bit better. Make your lock code a lambda. Well, this is even better, right? It's its own function. Yeah, RAII is a big thing in modern C++. So this maybe hides that RAII a little bit by, it still does it here, but it's sort of in the strong named scope, right? It actually has a name and then we can name it. So this actually makes it probably more readable, so it's a good thing to do. Okay. We're gonna want to do the same kind of pattern here. Well, the users can't call that function because it's inside of this impl. Clever, don't you think? So this impl, it's declared here, but it's opaque. You can't reach in. It's also private, so it's both private and opaque. They would have to somehow get into my CPP file to even know that there is a function called stop worker. One of the things I like about that Pimpl pattern, I have now 2 levels of hiding of my implementation. So we have that function, but it's really hard, if not impossible, without changes for a user to call it directly. Okay, yeah. So worker's going to have several things it can do, I think. Or maybe we'll just have it operate like as a state machine. Yeah, let's make a state machine. So we will have an anonymous namespace because no one else needs to know this, but see, these are the states in which the messaging class can be. And then enum class messaging, I will just call it state. And what are the different states? How about not logged in? Okay, what else? It's going to be pretty simple, but I'll change this later. It'll be just not logged in and logged in for now, okay? Later we'll add things like handshaking, like back and forth. We'll send our nickname and password, then we'll send our capabilities, and we'll wait for the capabilities to be activated. All that stuff. We'll not worry about that quite yet. Okay, the client has either not yet logged in or has logged out. There is no active connection. Okay, logged in. The client has completely logged into the server with an active connection. So obviously there's going to be some in-between states we'll add later, but for now we'll start with that. So I believe the state needs to be in here and not, I was thinking maybe we could make it completely inside worker, but log in and log out need to know. So here we go. Wait a minute, do they need to know? What if in addition to a state I have like a queue of actions? Yeah. Yeah, let's do that. So let's have a similar enum called action. These are the actions which the worker, the messaging class worker can perform. Action log in, and then action log out. And we'll say, establish a new connection and log into, with which to log into server. Establish a new connection to Twitch chat and use the new connection to log in. Man, I'm making typos left and right today. Okay. Log out of Twitch chat and close the active connection. Alright, so let's make a queue for action. So queue. I don't use the queue class often, but I think this one will be just fine. So we'll say standard queue of action. Actually, I'm going to have an action be a little bit more. We'll make this action type. These are the types of actions. And then, just thinking, I'll have like, still have a queue of action, but action will be a structure that has an action type in it, and then maybe some arguments. Like this. Oh, thank you, Setu12. What was it that you were streaming last? I don't quite remember. Was it? Yeah, you'll have to tell me. What's up with your stream? Shout out to Setu12. Let us know what you've been streaming lately. I'm kind of curious. Vulkan, that's right. Vulkan is the new graphics API to replace OpenGL. Although I was watching you and there's a lot of things that are the same, right? So is most of Vulkan just changing the API methods, but really the things like shaders don't change much? That's what it seemed to me. Like I understood what you were doing conceptually, but the function calls were different. Okay, this is used to convey what action to then convey an action for the messaging class worker to perform, including any parameters. Okay, so this is the type of action to perform. And it's going to be just that for now. And so we'll have a queue of actions. these are the actions to be performed by the worker thread. Actually, I'm thinking right now, Q might not cut it because, yeah, Q has a problem where you can only push on to the back and pop from the front, but we might need to push onto the front if like an action needs to be broken up into sub-actions. So we'll switch to DQ. DQ is sort of like the Q class most people use, and Q sort of like feels left out, but that's mostly because DQ is a lot more powerful and flexible, and Q is pretty simple. Alright, DQ of actions. Right, so now we have two conditions we could wake up for, right? Stop worker or not actions empty. Bit lower level to you. You're not actually using pure Vulkan this time, using a wrapper on top. Removes things from the pipeline created. But you were using like GLFW. I was using that with OpenGL. I'm like, oh, you could use it with Vulkan? I didn't know that. So yeah. Oh, you don't have to do pipeline creation, querying devices. Yeah, all that stuff is a pain, right? All that stuff like querying devices, memory allocation, that's because of differences in hardware and evolution of the API, right? So yeah, that makes sense that Vulkan is sort of cleaning up the API, removing a lot of the obsolete stuff and simplifying it for modern hardware. Yeah, so, okay, the idea I had here was we will make an action and we will say the type is action, action type login, and then actions push back action, and then wake worker notify, whoop, sorry about that, notify one, and then similar thing down here. GPU open repos. I don't know about that. Hard to deal with. This library is not from Chronos. Oh, it's not from Chronos. Oh, I see. You said it was a wrapper on top. Yeah. You don't like to go straight to the lowest level Chronos stuff? Oh, because it takes care of a lot of that stuff for you. Yeah, it makes sense. Okay, so we have login and log out. Oh, here, yeah, we need to... I do need to include my parameters, don't I? I'm just going to be lazy and just have, like, all of the possible parameters in this action structure, even though, like, only some action types will actually use it. We'll say, this is used with the login action to provide the client with the nickname to be used in the chat session. All right? Okay, and this is used with the login action to provide the client with the password, or with the... Actually, it's a token, right? OAuth token. Used to authenticate with the server. You wanted to just make a simple game. Other project is pure Vulkan. Really hard to modify. Cool. Very cool. Yes, so I need to actually stash the nickname here. Token, right? So as you can tell, the outer methods really are just wrappers for making these action objects and pushing them into the queue and waking up the worker. The worker's job is going to be to actually perform the work. So while, let's say, we'll keep it simple, while not actions empty, we will say const auto next action front. We'll do the action and then, so it'll be like switch next action type. And then when we're done, actions pop front. Actually, maybe it makes more sense to do this. So then we could push onto the front more actions and then, yeah, I like that better. So here, case, action type login. Just add some skeletons here. Should always have a default case, I think, otherwise sometimes you get warnings. The default case doesn't need to do anything though. Although I suppose if I should add this too. If I add diagnostic messages to this class, the default would publish a diagnostic message saying, hey, I was given an action. I don't know what it is, so never mind. Okay, so login. Here's the meat to how do we log in? Basically, we're going to be sending strings like this. So we're going to need the connection to be able to like accept a line, and we'll construct a line and send it. So it'll be something like, well, firstly we have to make a connection, right? Let me think about this. Is it going to be synchronous or asynchronous? I think the way I wrote what I'm going to end up using is this system abstractions network connection. I think that was synchronous, but let me check. I had to connect. Yeah, okay, so it's synchronous. So we don't need to like have an action to wait for a connection. We can just make it immediately. So we can say connection equals connection factory. And then we're going to say like connect, right? Actually, maybe the connection factory will establish the connection right away. Just think that starting with a high-level view of the API while having a clear goal for the project, and then as you get at a solid point with that, then you can convert your code to be pure Vulkan. Yeah, that makes sense. Yeah, one thing at a time, right? That makes sense. So should connection factory actually connect, or should we have a connect after we make the object? I think we should make it 2 steps like this, because between those we might want to register callbacks for like if the connection failed. Oh no, we already said that this was synchronous, right? Right, so it's either be true or false, right? And we need to start thinking about what happens. I'll just make a to-do here. What do we do if this fails? Right now the test doesn't test it, so we don't have to do anything. You get a thing to work with pure Vulkan, but at that level it's really hard to see everything works together. Yeah, and I think if you do it from a higher level, and then you kind of separate it into your code into pieces, and then you just eventually replace only one of the pieces that deals with Vulkan at the low level to do pure Vulkan. That's how I would do it. That would allow you to do things in steps that make sense, right? Don't know if I'm making any sense, but hey, I tried. Connection is connection factory connect. Yeah, so if we connect, we're going to want to start sending it. So connection send pass OAuth plus the token, right? Action token. Next action token. All right, and then we're going to want to send also the nick. And this should be auto. Oh no, I don't want that. We need to hold on to that. That's part of our state. So where do I put it? I don't know. I guess it can go here. So that's a shared pointer to a connection. This is the current connection to the Twitch server. this is the interface to the current connection to the Twitch server. If we are connected. Right? Whoops. Little slip of the fingers there. Alright. Connection. So we don't have connect or send defined yet. But I'm not going to let that stop me. So log out, let's just do this. So it will be connection. Well, hold on. What happens if we're already logged in and we're asked to log in again? Probably check for that, right? Test, we'll just say test needed. That's what I'm going to do from now on, I think. If I think of a path of code we'll need, but we don't have a test for it yet, we'll just do that. And then we'll just not care until we write a test for it. Then we write the test, it'll fail because we don't have code, and then we'll fill in the code, right? Okay, so log out. If connection. I think if we're already logged out and you ask to log out again, I think it should just do nothing. So only if it's not null, then we want to send a quit. And we put in the next action. What do they call it in the standard? Do they call it? I called it a farewell, but I don't know if that. They just call it a quit message. Actually, you know what I'm going to do? I'm just going to say message, because we can reuse that. Okay. This is used with multiple actions to provide the client with some content or text to be sent to the server, right? Okay. So we send it, and actually I need to think, is send is not synchronous, right? But then we can make a connection close also not synchronous. Sort of in the style that I did in previous streams where I had a close here and I had a clean, where it won't, what did I say, indicate whether or not to attempt to complete. Yeah, it will attempt to complete the transmission of the quit message before actually quitting. So if we say true, it'll match this other API. And then so we don't want to immediately destroy the connection. I guess what we'll have is we'll have another state, right? Yeah. Do we want to worry about that now? Or maybe I'll worry about that later. What does the test actually say? It actually assumes it's synchronous. That's not good. It actually also doesn't check for disconnection. Let's just leave. We'll put a test needed here. Close the connection after data is transmitted. I'll just leave that out for now. I do, whoops, I do need to make sure this is asynchronous like this login was, so we'll do the same thing here. So we'll have a logged out, and we'll set logged out delegate. I could type, and then we'll have the same kind of a wait here after log out. All right, logged out. Did Twitch already get rid of communities? Yeah, they did. I was watching Adam's stream earlier, and I'm like, oh, it doesn't say creative anymore. It says science and technology. I'm like, oh crap, I had to go figure that out before I start streaming today. So I actually think I kind of prefer the new way to do it, although there aren't very many categories that match. Like science and technology is the closest. I'd like the category to be programming. I don't know why they have that. Instead, they have software development as a tag. And, I'd like to put other tags like, I don't know, C++, but they don't have those. But I think it's better than before. It was just creative, which was just very generic. I like that about it, but what I don't like about it is what Adam pointed out, where if you do a search from the top level of Twitch, the science and technology is like buried, like several rows down. Yeah, so, and I've always thought of programming as not so much art, but more science. Because I'm not a very artistic person. I suck at art. So it was always kind of weird that programming was kind of lumped in with creative. But yeah, I don't like how science and technology is not prominent. It's like all these games and you have to go scroll really far down to find science and technology now. But interestingly, it matches up better with the tags and categories in YouTube. So probably when I export my videos, it'll match up with the tags in YouTube better. All right. We don't have a logged out delegate yet. Oh, I need to be remembering to drink my tea so I don't lose my voice. Programming is more logic. I think if it, yeah, logic, math, and also procedure. I guess artwork sort of has procedures too, but it is more rigid in programming. Like test-driven development, there's a sequence of things you do. So there's like a rhythm or a cadence. You do step 1, 2, 3, 4, repeat, right? So there's that too. This is called the set of a function to callback to happen when the user successfully log, or it just doesn't have to be successful. Completes logging out of the Twitch server. How about that? User agent completes logging. Yeah. So I don't know how many people are watching, but I had this thought. I don't know if what you guys would think about it, but I'm not allowed to have a camera, so that's why I don't have a like Adam does. I don't have you can't see my face because my family doesn't want me to have that. But I do have a laptop, and I thought the other day, what if I took my laptop, a beach chair, and walked to the beach and just coded from the beach, and you could see the ocean in the background. That audio issues aside, because it might be loud, like, would that be, I don't know, more entertaining or not? I have to try that out one day. And then you can see what I look like and see the beach and all that. That might actually work out. Might be a little bit more relaxing. Okay, this is not right because this should be out. And I did not declare that type yet. Well, I have said who's 12's approval, so I'll have to try it. I don't know about the data situation. I don't know if I have like Verizon. I don't know how good the data will be from the beach. I live like 3 miles from the beach, so it's a decent walk. But we all have to get out and get some exercise once in a while, anyway, right? The user. Okay, I have this text elsewhere, don't I? Yes, right here. Yeah, so if I'm in a public place, like at the beach, then the objection to having a camera feed goes away, right? This is the function to call on. The other problem is I won't have 2 monitors. So it'd be kind of a juggling act, especially if I have to have like a window with private info on it. It'd be sort of a juggling act to do the streaming. I did test on my Mac Pro, and it does stream pretty well, so technologically it's doable. Okay. Okay, we're good. Okay. Add that to the state. I'm not sure I understood. It's all fine. This is the function to call when the user agent... Oh, again, I have that documented here, don't I? Yes, there we go. Oh, wait a minute, that's not right. I copied from the wrong spot. I need to be looking more closely, not going on autopilot. Okay. Did I make the mistake up here? No, that's fine. You don't like the new Twitch thing? Like everyone is in the same place? Oh, you mean the browsing? The categories and such? Oh, hey there, Offbeat Jenny. How's it going? And maybe Twitch will change their mind. Although I don't know. It's more towards grouping games together, right? So programming and other creative stuff being sort of a minority. Maybe we just have to kind of live with it. I used to think that no one did programming on Twitch, and I kind of wanted to do this kind of thing, but I didn't know you could do it. And it was several years until I realized, hey, people are doing programming on Twitch. Wow, that's what I wanted to do. Let me try that. Because you go to Twitch and it's all about games, and so it's not obvious that they have alternative things. Okay, what was I... I'm getting distracted, sorry. Log out. Oh, I was doing the test, right? Okay, yeah, so that compiles now. Oh, I missed something. Oh, I didn't do send or connect yet. Oh, you know what? This connect also needs a test as well. Let's... fold that into this sort of like... actually, let's go and add the connect to the test. So... how do I write this down though? Expect true mock server connected is connected. And maybe what I'll do is if they don't connect first, yeah, we'll have another flag. We'll call it what? Connection problem. Was there a connection problem? Okay, so is connected. And was there a connection problem? So if you haven't figured it out, I should have said this explicitly before, but this mock server, it's like our helper and our right hand, where the tests are our left hand. So if you think of the thing in the middle was what we're testing, the test is one hand, the mock is the other hand, and so they coordinate together. The test sets up the mock to pretend to be Twitch, and then it goes through the unit we're testing, and then it asks the mock, which is our right hand, hey, did he do what he was supposed to? Can't wait for John Blow to stream. John Blow. That sounds familiar. Isn't that guy already streaming? I think he is. I just don't remember which stream he's on. Yeah, Naysayer 88. Isn't that John Blow? Or you can't wait for him to go live. Oh, you're saying you can't wait until he starts his next stream to see what his reaction is. Yeah, well, you have to let me know if you see it first. I don't. You don't. Yeah. He's sort of a. What do you say? I have a few friends like him that they have very strong opinions about things, right? And it's always interesting to see what their reaction will be about something that is controversial, right? Okay, so let's see. Yes, so what is our mock gonna do? Okay, yeah, I need to have this connect and send in the first place. So connection, virtual, bool, connect. I don't think we need arguments. Oh, no, we did, right? No, we don't. And then send, right? All right, so let's document this. So this method is called to establish a connection to the Twitch chat server. Return an indication of whether or not the connection was successful is returned. All right, next. This method, this is where it's a little bit different. It's going to be, doesn't send synchronously. I should actually say this. This is a synchronous call. The connection will either succeed or fail before the method returns. Okay, this method queues the given message to be sent to the Twitch server. This is an asynchronous call. The message may or may not be sent before the method returns. How's that? Up. This is the line of text to send. How do I want to say it? I don't want to include the carriage return line feed part, because I want that to sort of be sent automatically. Or do I? Maybe I kind of want to build it in here. Like this, right? Maybe that would be better. Yeah, because then send could construct a multi-line thing. So we just need to define that. I have that elsewhere, so I can cheat and totally search for it and then copy it. Right here. And put it here. Oh, not there. Here. Makes you want to write down notes? Or you mean like because I have this huge OneNote note page with everything? That's good. I found that I always want to remember things that I forgot to write down. I always say, "Oh, damn it, I forgot to write that down." It's always nice when you do write things down and then you can find them later. Or if you're saying that I'm giving you things you want to write down, that's good too. Okay, this is the required line terminator. We're not doing encoded chunk body lines. For our lines of text sent to or from Twitch chat servers. I always seem to remember to forget. I forget to remember, and you remember to forget. Yeah, I don't know. I can't remember which one's better. Anyway. Yes, the whole thing there with the CRLF is because I just want to say this is the text to send and be generic. It's not a line. It could be multiple lines. It could be half a line. Okay, Okay, so that's complete for now. Our mock needs to implement it though. So the way you do it is you replace equals 0 with an override. And that's a new thing in modern C++ as well, this override thing. That does two things. It makes it so when you read it, you're like, oh, it's a base class method. It's not a new method. It's an old method we're replacing, overriding. The second thing it does is if you misspell it, the compiler will say, oh, there is no base class method called that. You have a typo. Whereas before, like if you do that, you don't know. You don't know that you misspelled it. So it's a useful thing they added to the language. And what do we want to do here? Probably need to have some properties, right? Properties, properties is connected, right? And actually we can return that from this. Was there a connection problem? Well, let's make a flag for that. Connection problem. We'll assume there isn't at first, be optimistic. And a connection problem would be what? If connected is called twice, maybe? And what else? Probably if send is called and we're not connected. Other guy. Connection problem true. Actually here, we'll just have it return early. Because I'm going to do more stuff in send, right? And very soon now, actually. Okay, it'll build, but I'm not done. No, what? It didn't build. Oh, we have to return. Return, actually, here we can say return false. And here return true. There we go. Okay. Was there a connection problem? Doesn't get all the problems, right? Oh, wait a minute. What does connect mean? Actually, I think it is just this, whether connect was called. That's all we wanted. Right, so send needs to interpret a little bit. So we have to do a little bit of parsing here. Not too much, though. So we need to recognize those two messages, right? So if message.length is at least... Well, do we even need to do a length check? Can we just do substring? And what? I need to look at my manual. Hold on, pulling up the velocity, which is my offline manual. Offline manual. And I can say vector substring. Can I just do substring? No. If I just do substring. Oh, it wasn't vector anyway, it was basic string. Alright. Yeah, this is the part I can never remember. So yeah, we can request a substring extending past the end. So we can say like 5 characters equals pass space, right? And if if message is less than 5 characters, it'll still work. Feels like you've walked into the official advanced classroom in school. I'm sorry. Or is that a good thing? I don't know. Basic string is the real name of the class. String, it turns out. Where does it say it? String is a type def for basic string. Where is it? It's here somewhere. Yeah. So, no, where am I? I guess this is it. And I've already lost it. Lost my place. Yeah, type def. So standard string is a type def for standard basic string char. So it turns out you can have basic strings of wide characters and other things. And this you would use for like 16-bit characters, like for old style Unicode UTF-16. I don't know why you'd use one of these, but maybe if you're a weirdo. But most people I've seen just use string. But yeah, it turns out under the hood it's basic string, and it's a template where you could have different types for character. It's not the derived class. It's that basic string is a template, and so string is a binding of the template with char. Yeah, templates can be ugly though. Like if someone was learning C++, I would probably start off with steering them clear of templates, except for the standard template library templates like vector. Making your own template, I think, though, you shouldn't do until you're pretty comfortable with the language. Oh, hey there, Adam. No audio right now. Okay, we're going to switch to botland then. Actually, let me find a good... we're in a pretty good stopping point. I was just about to make a mock Twitch server, and this is a little bit involved, so I kind of don't want to get into it until I have a good block of time. So it's actually a pretty good place to stop.